Good morning, my student. In this video, I'm going to discuss and answer different questions from chapter 4, section 3. I will start with question number 20, page 115. So please open your textbook on page 115 and try to read question number 20. Now, in question number 20 here, I will try to solve it here. Question number 20, 115. Three isotopes of oxygen are oxygen 16, oxygen 17, and oxygen 18. Write the symbol for each, including the atomic number and mass number. Now, first, you have to memorize the first 21. Most of our question will be about the first 21 element in the periodic table. That's why I'm asking you, my student, to try to memorize these first 21 elements in the periodic table. Here we have oxygen. In this question, we have oxygen, oxygen 17, and oxygen 18, and oxygen, I forgot it, the first one, oxygen 16. Okay, now to write the symbol of each isotope, we will write first the symbol of oxygen, O, and O. This is oxygen with mass number 16, 17, 18. Now I want to write the atomic number. You can memorize it, or you can return to your periodic table. Here, as you see in the key, the number written up the symbol of the element is the atomic number. Oxygen is here. Atomic number of oxygen is 8. Three isotopes of oxygen. Three isotopes of oxygen. For question 21, 115, read it, please, silently, and think about it. Three chromium isotopes are chromium 50, 52, 53. We have chromium, three isotopes, (50), 52, 53. How many neutrons are in each isotopes, given that chromium has an atomic number of 24? Chromium Cr, Cr, Cr. 50, 52, 53. Atomic number, as it says in the question 24. Now, to calculate number of neutrons, in each isotopes, number of neutrons equal mass number minus atomic number. Now, to find the number of neutrons, 50 minus 24, 20, 26 in the first isotopes, 52 minus 24, 28 neutron, 53 minus 24, 29 neutron. Number of neutrons in each isotopes. In each isotope. (26) for the first isotopes, chromium 50, 58 for chromium 52, 59 for chromium 53. That's how we can solve question number 21. For question (22) and 23, for questions 22, 23, please open your textbook, page 118. 118. Question 22, 118. Boron, it says, boron has two isotopes, boron 10 and boron 11. Boron 10 and boron 11. We have two isotopes. Now, which is more abundant isotopes? Given that the atomic mass of boron equal 10.81 AMU. Now, which isotopes is the most abundant or more abundant than the other one? Now, as you see here, the value of the atomic mass of boron atom is 10.81, and this number is almost equal 11. That's why boron 11 is more abundant more abundant than boron 10. Why? Because the value of the atomic mass is almost equal 11, not 10. Now, to solve question number 23, page 118, in this questions, it says, there are 3 isotopes of silicon. We have 3 isotopes of silicon. The symbol of silicon is silicon. Let's write first the name. Silicon 28, silicon 29, silicon 30. We have 3 types of isotopes of silicon. 28 with the mass number 28 and 29 and 30. The atomic mass of silicon, the atomic mass of silicon equal 28.086 AMU, atomic mass unit. Comment on the relative abundance of these 3 isotopes. Now, for this question, as you see, the atomic mass is almost 28. Is almost 28, not 29, not 30, and the difference between the 2 numbers is very, very small. This mean silicon (28) must be by far the most abundant the other 2 isotopes. The other 2 isotopes must be present in very small amount. Sorry. Silicon 29 must be the most abundant isotopes in nature for silicon. Silicon 28. Why? Because the difference between the atomic mass of silicon and the mass number of silicon 28 is very, very small. And the abundance of silicon 29 and silicon 30 is very, very, very small. Now, silicon 28 is the most abundant isotopes. Let's see question now. The last question I'm going to solve with you or discuss or answer with you is question 24. Please try in your home to solve question 25. 24 and 25 almost of same types of questions. It is these two questions are, we can solve it by the same way but with different numbers. Question 24, page 119. In this question 24, it says here, the element copper has naturally occurring isotopes with mass number of 63 and 65. We have two copper isotopes, 63 and copper 65. Now, okay, the relative abundance يعني نسبة الابندنس اللي هي نسبة الوجود and atomic masses يعني الكتلة الذرية للأيزوتوبس الأول 69.2 and the second one 30.8 and the atomic mass for the first isotopes, as it says, 62.93 AMU and the second one 64.93. He asked us to calculate the atomic mass of copper. Atomic AMU, atomic mass of copper equal now here we have two isotopes. We do this 2 because we have two isotopes. Multiply the abundance with the atomic mass of each isotopes times 62.93, 30.8 times 64.93 divided by 100. The value, if you calculate this number, equals 63.546. As you see, this value, the atomic mass of copper, is almost closer to the atomic mass of copper 63. Why? Because it is more abundant than copper 65. That's it for today. Please try to write the answer of all questions we have done in this video and to question 25 on page 119 as a homework. If you can solve it before our time in this class is ended, please send it. Otherwise, don't send anything after 4 o'clock. Thank you.